Hello, we're Team 14, comprised of Sahil, Majda, Claudia, and myself, Daniel. Our project aims to develop a predictive model for changes in stock prices, with the goal of assisting investors in making informed decisions. To achieve this, we utilize a diverse set of data sources and analytical techniques. We gather financial news from reputable sources, such as Reuters, the Wall Street Journal, CNBC, and the Financial Times. Additionally, we collected historical stock price data from Yahoo Finance. For sentiment analysis, we leverage social media, specifically from X, formerly Twitter, and apply the Natural Language Toolkit NLTK from Python to analyze sentiment patterns. Now, we decided to focus our analysis on the company Tesla. Tesla CEO Elon Musk is a highly influential and controversial figure. It's become apparent that Musk's actions and statements often have a significant impact on Tesla's stock price. Therefore, we chosen to narrow our scope to investigate whether there is a tangible correlation between Musk's behavior as reflected in social media and Tesla stock performance. Next, Claudia will provide more details on the nature of the data used and how it was collected and processed.
Hi, I'm Claudia, and I'm going to talk about the data that we have collected and used in our models. So, as Daniel said, we try to predict Tesla's stock price for each week. So for that, we collect different financial data from Yahoo Finance. This is Tesla's stock price, SP500 variance, because it provides us with the volatility of the market, and Tesla's competitors' prices such as Ford, Toyota, Nissan, or General Motors. Additionally, we obtain Tesla's Wikipedia page views because we think this will give us information on how much interest do people show for Tesla. And finally, we want to show how sentiments for Tesla shown in social media affect its price. And for that, we want to develop a sentiment analysis on the tweets obtained from the different financial sources. We have also done some cleansing and processing of the data. For the tweets, we have divided them into weekly tweets and eliminated links, mentions, and duplicates. And for the financial data, we match their index to Tesla's stock price index so that we have the same daily data for all the sources. And finally, we check for missing values, and we input them with an average of the first and last values in the interval. We can see an example for Wikipedia page views in the plot in this slide. Lastly, to develop the sentiment analysis for the tweets collected, we have used a library called Vader. It provides a score from -1 to 1 for each word of the tweet, depending on whether it has a positive or negative connotation. For the sentiment score, we have used a compound score, which is the addition of the positive and negative scores for all the words in the tweet. Then, to get a weekly sentiment score, we average the score of the tweets for each week.
So to predict next week's stock price for Tesla, we used 5 primary models: linear regression, basic cart with cross-validation, random forest with cross-validation, gradient boosting, and an ensemble of the previous 3 tree-based models. Our results showed that they all have pretty high out-of-sample R-squared, all above 0.95, and they all have average percent test error below 7.5%, with linear regression and random forest being below 6%. For context, average percent test error means for the average of the percent error between each predicted stock price and each actual stock price aggregated across each of the weeks. However, when we put these in context, we get a bit more reasoning into how these results came about. First is that some of the features like tweet sentiment clearly did not have a strong correlation with the actual stock price, while the stock prices of the car vendors did have some correlation with that of Tesla. But I think the biggest aspect here is that out of all the features, the one that had the most weight was the previous week's stock price rather than some of the non-financial features.
Thank you, Sahil, for explaining the models that we tried and also the result that we had using these models. So as a conclusion, we can say that the sentiment analysis that we came up with isn't really correlated with the prices of the stocks. Also, as we can see in the graph here, which is the predicted values versus the real values for the test set. For the linear regression, we can see that the prices of the week are mainly the prices of the previous week. And this is a tendency that we saw in most of the models. The models mainly rely on the previous week's price. Also, our metrics now measure how close we are to the real price. However, most approaches on the literature that we've seen try to predict either a tendency of the price, so either going up or down, or the efficiency of a particular strategy. So for the next steps of our project that we'll be working on for the rest of next week is to, rather than predicting a specific price, trying to predict a tendency and adjust our metrics to reflect that. Something else that we wanted to explore is evaluate if some Twitter's accounts have a better sentiment analysis than others. So as Claudia presented, we've used different Twitter accounts with each of them a different amount of tweets from them. So the idea is to see if any of these accounts predict better the tendency of the price. We can assume, for example, that the type of tweets that just specify Tesla might have more fake news and might be lowering the quality of our sentiment analysis.